Hi, Keir. Yeah, I can hear you.
You're audible.
Thank you. Okay, I think we have a not totally packed agenda, so we should probably get started close to time, which is now. I'm Chris. Keir and Natalie are also on, and we have 34 other, apparently, 34 other people on the meeting. So we'll have to select a notes taker. Great if somebody could chime in the chat, perhaps. I think I can put the link in here to the code IMD. I never get the word right, to the notes. So then the link to the notes is in the chat. It'd be good if somebody could volunteer to do some note taking. Someone has to sign up to take notes or we can't go. Oh, maybe somebody did. Natalie says, but she's going to need some help keeping track. Okay. Moving forward, this is the Sidrops meeting at virtual IETF 110, supposedly in Prague. I'm missing the Indian food. George says he's also going to help out with the notes. Thank you, George. Whoops, wrong window. Here's a note well. Hopefully the chair slides did just barely make it under the buzzer. So if you want to follow along yourself or on slide 2, you can download the slides from the meeting materials page, which I think I can't actually get to right now. Anyway, everyone's read this, I'm sure. If you haven't, please take time to read it after the meeting is over. We have an agenda. We have 6 presentations. It's early morning and I can't count. Do we need to add anything to the agenda other than these 6 items?
I think we're good, Chris.
Okay. Terrific. Then I think the first person to go is Ben. I believe I have Ben's slides.
I'll do my own if it's all the same to you.
Oh, perfect. Even better. Let me stop sharing mine. It's always preferred when someone does their own. All right.
Yeah, there's something very awkward about having to say next slide every couple of seconds. Okay.
Right.
I'm Ben Madison from Work Online Communications, and this is an update on the RPKI max length document, which has been around for quite a while, but hasn't been spoken about at one of our meetings for a little while. These are my co-authors. A quick recap of what it's about if you haven't read it for a while or you haven't read it at all. It's a fairly short document. It's targeted at BCP status, and it describes a hijack attack type that is made easier by the presence of a rower that authorizes a prefix to exist in the routing table that is longer than that which is ordinarily announced in BGP. It's been observed by a few people that the presence of the max length attribute in the rower very often gives rise to what we call in the draft non-minimal rowers, which make this type of attack more easy. Because a rower that is issued for a maximum length, which is the same as that which exists in BGP, a hijack will always be fighting for best path because of its longer AS path length, whereas a more specific hijack doesn't suffer from that. So if it's authorized by the same rower, then that attack type becomes a hell of a lot easier. And there's a simple recommendation contained in the draft, which is that you shouldn't do that. And more specifically, you shouldn't use the max length attribute unless you've thought carefully about this attack vector. Most of the changes that have taken place to the document recently are editorial in nature. The longest section, section 3, is an example of the type of hijack that this attack envisages. The content hasn't really changed much, but it has been edited for readability to help make the example a little easier to follow. It now describes the type of attack that we're discussing, and how that's made easier by the presence of what we term a loose rower. That is a rower that has a max length attribute that is longer than the ordinary BGP announcement. What a strict rower looks like in the context of that example, why the strict rower mitigates the attack, and why it's possible to still launch a similar attack, but it's substantially less likely to be effective in that it's less likely to attract any actual traffic if the rower max length matches the BGP announced max length. There's a measurement section which describes some measurements that were taken a while back that observes that this kind of vulnerability is very prevalent in currently issued rowers that have the max length attribute. That's been revised to make it a little bit longer, but hopefully a little bit clearer, because the first few times I read it, I found myself going back to the beginning of the sentence over and over again. There is a question that I have for the working group, which is that the measurements in the draft are from 2017. I would like to know if anyone is aware of any similar studies that have taken place more recently, and if so, whether we should incorporate that into the references. Or failing that, if anyone has any reason to believe that the numbers that are discussed have changed significantly. From my own observations, I don't believe that they have, but my observations are, just that. They are things that I've seen in the operational side of things that certainly wouldn't qualify as an academic study. In section 5, the background to this draft, this came about because of a study done by a couple of my co-authors where they observed this phenomenon in the wild. And that research was centered explicitly around the use of max length in the rower, which is how this draft got its name. But the intention of the draft is not to say that the max length attribute is bad in and of itself, or that it presents a vulnerability in and of itself. What we're trying to describe is how to minimize the attack surface that's available for this type of sub-prefix attack. And so that section has been reworded to say, don't create, or at least try not to create, if you possibly can avoid it, non-minimal rowers. When you're creating rowers, think carefully about the use of max length so that it doesn't result in non-minimal rowers. And we've tried to clarify the fact that this creates a bit of a tension where there's an operational requirement to be able to deaggregate fast. The obvious example is in the face of a DDoS attack, where in order to start mitigation, one needs to deaggregate and get longer prefixes announced. But we've clarified that there are other examples where you need that sort of an operational response, and that not having a loose rower in the system already, given that RPKI data does not reflect in all corners of the world simultaneously after you create a new object, there's a tension there, and we call out some possible solutions to that, all of which are pretty bad, to be honest. None of them are ideal, and they require kind of educated trade-offs to be made by the operator. But those are enumerated, hopefully fairly systematically. And I think I'd just like to call to the attention of the working group that this is a gap that we have at the moment. And we should probably think about potential solutions to it, but this draft is not the place to document them. I see Alexander's in the queue. I can take questions now if you'd prefer. It's gone. Okay, and the final section where there's been changes, and these are probably the most substantial changes, is in the RTBH signaling section. It's my personal opinion that previous versions of the draft overstepped the mandate of a BCP document pretty spectacularly. The old versions essentially recommended a new validation procedure, which was not the validation procedure in 6811. And as far as I'm aware, I've never come across a BGP speaker implementation on which they could actually have been deployed. So that text has been removed. It's not to say that the recommendation was necessarily wrong, but it certainly didn't belong in a BCP draft. The revised text simply calls out what is hopefully obvious to everyone, which is that RTBH signaling and origin validation are not happy bedfellows today. It specifically says that a solution to that fundamental problem is out of scope and it punts it down the road. And the only recommendation in this area that it explicitly makes is that making use of an RTBH signaling mechanism, or making such a signaling mechanism available to your customers or peers, is not a good enough reason to either create or require the creation of non-minimal rowers. And so that hopefully fixes the most fundamental problem that existed in the previous version of the draft. As a result, I think the authors are all on the same page in terms of believing that this is now pretty much a finished piece of work. I'm happy to take questions and respond to comments, and if there are other changes that people think are necessary, then we can look at incorporating them. But failing any of that, I think we're ready for the chairs to start a last call if they would be so kind. That's all.
I think maybe Alex. Question. Sorry, I was.
My name is Alexander Azimov, Yandex. Ben, thank you for the slides, and I have a question. As you may remember, I have a different view on this draft, not very different. But my question is, by these changes, what kind of hijack you are trying to address? Are you trying to address malicious activity, or still you are trying to address mistakes that are mostly happening in the world?
So Alex, I was struggling to hear you a little bit, but I think your question is what type of hijack attack vector this is aiming to solve, right?
Yes, correct.
So the specific attack vector is where you have a ROA issued covering length up to, say, a 24 for IPv4, but in the ordinary course of operations, all that's announced in BGP is some aggregate that's shorter than a 24. And the attack vector that we discuss is that makes it fairly trivially easy for a hijacker to spoof the AS path, announce that upstream to their peers or transits, and become best path for that prefix because they are the only longest match for anything that exists in the routing table. And that's made possible by the fact that the longer prefix is authorized for origination, even though it's not ordinarily originated. Does that make sense?
You are speaking about intentional hijacks, not a mistake, but intentional activity. And in this case, I have. Sorry.
So I think it's mostly about intentional hijacks, because making a mistake of this kind would be pretty hard to do using most router implementations. But it would, you know, if someone managed to make this particular type of mistake, it would protect against that as well.
I do agree that this kind of solution can be helpful only in case of intentional hijacks. But imagine that there are two islands. One good island where there are ISPs assigning rows, where origin validation is happening, and bad island, where is no rows, no verification, plus there are some hijackers living there.
Mm-hmm.
And in your scenario, if such intentional hijack is happening in the bad island, and there, of course there is some place in between of these islands, there will be a more specific prefix, which will begin to spread from this island to other places and so on. What you are suggesting that your good island will be protected against this activity, but all space between these islands will have a high chance to use the more specific prefix. And in response to this hijack, the victim will not be able to advertise its own more specific, because the row will not be permitted. So in case of partial adoption of route origin validation, I believe this kind of strengthened rows, or not strengthened, but as a recommendation, do not use max length as it's used today, will can result even in worse problems, when your address space will be hijacked and you will have nothing in response at the moment. That's my comment.
So, okay, so if I'm understanding you correctly, you're saying that by issuing only a strict rower, you're limiting your ability to respond to a sub-prefix hijack, because you won't be able to, you'll essentially lose the ability to propagate any deaggregation that you do past your immediate your immediate neighborhood to get to the bad island. Am I understanding you?
And if you're, for example, applying even egress origin validation on your own router, then you will not able to pass it even from your own ISP. Of course, you can remove it, but anyway.
Yes, that's probably a valid criticism. I think that it is a pretty unlikely scenario because of where origin validation is happening in the wild today. It is not the case that there are kind of readily distinguishable islands in the internet topology where origin validation is happening and where origin validation isn't happening. It's increasingly the case that the large transit networks in the kind of topological center of the internet are doing origin validation, and so I think that there is, I think that we are better off optimizing for the case that we're better off optimizing the protection that the existence of validating parties creates, rather than optimizing for the case where you need to propagate a defensive deaggregation into a non-validating network. I hope that makes sense.
I think yes, mostly, but I I think it will be great to make this security consideration also cited in the document. That you may have some problems because of.
Alexander, I can't hear you anymore. I'm not sure if anyone else can.
Can you hear me now?
Can hear you now.
Oh, great. So my suggestion is to make this kind of scenario also cited in the document, so that the implementers, the network operators, will be aware that by issuing this kind of RO, they are somehow limiting their response opportunities.
Yeah. What would be really helpful is if you could send an email setting out the kind of the kind of problem that you envisage, so that we can make sure that we're on the same page, and then we can look at how we go about incorporating that. Because I think that it's a valid point. I struggle to see exactly how we articulate it with reference to what the internet looks like today.
Okay, let's try to find a solution together. Thanks.
Thanks.
I think the next was Rudiger, and then Sriram, and then we got to skip to the next presentation. So make it quick.
Okay, I think you can hear me. When I talk, unfortunately, I lose the other direction of the audio. Unfortunately, I haven't been reading the text for a long while. What I wonder is, do we tell and do we want to tell that issuing any ROA for which we are not actually doing a valid announcement or intend to do it short time can be viewed as an invitation to an attacker who can fake the AS that's mentioned in the ROA to take over. The fact that the max length is a way of doing the most dangerous type of attack vector, well, okay, kind of seems not really to be the most important thing. So I switch off my mic and I will not hear you for a couple of seconds.
Go ahead, Ben.
Okay, Rudiger, hopefully you can hear me now. Chris, have I got time to respond to that?
Yes, please.
So that point is pretty much exactly what I was driving at on the slide that I've just gone back to. The previous wording seemed to suggest that max length in and of itself was the problem. And we've clarified the recommendation section so that it's clear that the problem is exists whenever you have a rower in the RPKI that covers a prefix that is not usually announced, and in particular, a longer than usually announced prefix. And that the use of the max length attribute is just a very convenient shortcut for people to create those kind of problematic rowers. But yes, I completely agree that the fundamental problem is covering a prefix that's not usually announced, and that, you know, the max length thing is just a commonly observed symptom of that problem.
Sriram?
Yeah, I just want to make a quick observation, which Ben may have already mentioned, but I want to emphasize in response to Alexander's comment that even when a regular like prefix is announced, is hijacked and not necessarily maliciously, the owner of that prefix, which is hijacked, somewhere in the network away from you, that hijack will be dropped in the part of the internet where the ROAs are implemented and the ROV validation is implemented. So you are losing visibility even when it is a normal prefix that is hijacked, even non-maliciously. So the loss of visibility is there. So when we discuss this further on the list, I think I would like you to keep that in mind as well. Thank you.
Okay. Thank you very much, Ben. The next person should be Tim, whose presentation I will show, I hope.
All right. I see lines moving on my screen, so I guess you can hear me. I just don't see my slides just yet.
Yeah, just 1 second while I find the right thing.
Yeah, don't worry.
Okay.
Right. Okay. Maybe next time I'll do my own slides, but not this time. Let me try to be quick. So there's an update to the deprecate rsync document. Indeed, it's been rechristened to prefer RDP. I think that, well, the change here is really one of emphasis. The document that was there always said that we had to go to a place where we prefer RDP first before we can consider deprecating rsync altogether. But we're trying to make this more explicit right now. So the first objective would be to promote RDP to a mandatory to implement protocol and make it preferred so that the operational dependence on our rsync infrastructure is reduced. And I think with that, we will already achieve a great deal of the issues that at least I see with rsync. Next slide, please. Yeah. So there were already a couple of phases in the document. The current document makes a slight change because if you remember, phase 0 is essentially where we are today, where RDP is optional and rsync is required. What was not clear to all implementers before is that there was a strong desire that if RDP is unavailable, a relying party software should or indeed must fall back to rsync. Because if you look at the current text in the RDP RFC, then it actually says it could fall back in a small print, actually. So in the current document, we suggest that since there is a feeling in the room that if information is available, it should be used, then this wording needs to be much stronger. So perhaps it should say must use alternative access mechanisms if available. The other change in this document is that or in this revision, I should say, is that RDP already said, so 8182 already said that publication servers that do RDP must make sure that all files are available. But it does not explicitly say that things need to be highly available in 6481, because that only talks about rsync. So the suggestion here is that even today we would say, if you do RDP, then you have to be serious about it. Then you have to make sure that it's available as well. So with that combination, we hope to avoid problems that we have been seeing. Next up would be that repositories must all support RDP as a high availability service, and that relying parties must still fall back to rsync. So the only thing this changes really is that there's a requirement for all repositories to implement RDP. And then the last phase would be that relying parties must all support and prefer RDP if available. But they must still fall back. I think that if we do all of this, then the practical operational dependency on rsync will be much reduced, and at least my immediate concern with it could be addressed. Doesn't mean we have to stop here though. But first, let me, I guess, read out the questions that were raised. So with regards to fallback to rsync, currently the suggestion just says must use alternative methods. It doesn't say anything about a strategy that should be used here. There were concerns raised about if an RDP server would be unavailable, that all relying parties in the world would immediately start hammering rsync servers, and you would see immediate problems there. So we may need to take some feedback on that and include some words on that. Another observation is that even in phase 0, like today, well, if RDP is available, then I believe it will already be good if relying parties who choose to support it today already prefer it and stop hammering rsync servers. So we may want to have some words on that as well. Next slide, please. So yeah, again, the longer term objective, I think it's still good if we would remove the operational dependency on rsync altogether, because it would allow us to simplify the code in relying party software. It will also allow us to simplify repository operations, because you don't have to run these servers anymore. But of course, I understand that before we can get there, we need to do a couple of things. We need to get operational experience and be confident that it's actually safe to do. And there's another question that was raised, because we have rsync URIs in the RPKI all over the place. And if we need to get rid of them, then that actually is not so trivial. Next slide, please. Yeah, because we use these names as identifiers. It's very useful for debugging, for talking, for reporting, but also they're oftentimes used by relying party software to build up a hierarchy of things to validate. So you can actually build up a hierarchy in a different way, but it would require some serious thought. If we would replace the rsync URIs with another type of identifier, then we need to update at least the certificate profile, because that currently requires it. And then there's all the interactions between CAs, a parent CA, child CA, and publication server that would need to be addressed as well, because there's restrictions there in the URIs that are to be used. Like, for example, if you set yourself up as a publisher on a remote publication server, you get a response that says, this is your rsync jail where you're allowed to publish. So those things would need to be changed. And of course, the certificate sign requests would include different kinds of identifiers that would also have to be honored. So this is just to say there's quite a lot involved. Next slide, please. So yeah, my proposal would then be to really focus on preferring RDP for now, and perhaps actually split this document into two and look at deprecating rsync as a later stage, as a separate step. We can already start this initiative if people are interested, but yeah, I think it's a lot of work, and I would not like it to block progress on preferring RDP. So that would be my proposal to the group. And I have a final slide. I forgot what I put on it, but I'll remember now. Yes. Yeah, so the document currently includes a status overview, which is kind of informational only, really, but it's to give an idea of where we are. So RDP is already supported by most repositories. One RAR is planning to deploy very soon. It's also supported by delegated RPKI software, and there's one repository out there that's not doing it yet, but there is software available that can do it. So I think there is an option to go there in future. Furthermore, RDP is also supported by 6 out of 7 validation implementations, and the 7th is developing it right now. Of course, I don't expect a yes or no answer here to this question, but my ambition would be to aim for wrapping up the Prefer RDP work sometime this year, preferably towards the end of it. And where currently we have 3 different phases defined, I'm not so sure that we really need to have like documents for each phase, because in practical terms, I think we're pretty much close to it being done by everybody anyway. So we may then have this plan, which is good, but at the end of it, produce one document that does the updates that we think are needed to the current RFCs in one go, and not have like 3 different published documents for that. With that, I would like to hand over to the queue, I suppose, because that was all I had to say for now. And I see Job was first and then Randy, so go ahead.
Job Snyder, Pasley. I'm not entirely sure what publication for phase 2 end of 2021 means to the RPKI community, but I do want to point out that a relying party software implementation I contribute to supports previous versions up to 1 year. And looking at my RRDP logs, I noticed that this industry appears to need almost up to 1.5 years for 95% of RPs to upgrade. So I think that phase 2, whatever publication for phase 2 means, should factor into account that there is essentially a 1.5 year lead time. This was my comment.
Right. Can I respond to that? Yes, I appreciate that. But I think publication for phase 2 would essentially mean that there's then a requirement for current implementations to support RDP. It doesn't go as far as deprecating rsync yet. So in that sense, I think that nothing should break at that point. I also believe that even if you publish a document that says that, for example, all repositories have to support RDP and not all of them do it just yet, you can still publish a document that says that you really ought to do it, in my mind. But because you still don't say to relying parties, you don't have to do rsync anymore. So I hope that clarifies my thinking on it. My objective definitely is to not break anything by publishing anything. So, okay, Randy, do you want to comment further?
I think this current document confuses 2 things, which is the plan and the criteria in the plan, et cetera, and what the current state of various deployments are. And I think my personal opinion is that the document should stick to the former and that we publish regular documents of the second flavor that are usually, the custom is their implementation reports and interoperation reports, which are also internet drafts. It's not a format change, it's a content change, so that 3 months from now, we're not looking at this document and say, oh, but we've already A, B, and we've changed our mind on C. And
Okay. Yeah, I would be quite happy to take out the implementation status report and handle that separately. I would also be happy to take out the words that talk about the phases beyond, let's say, to really deprecate rsync and perhaps launch a separate effort for that. And then I think the document will be focused on just the first, well, phase 0, 1, and 2. Would that be in line with what you are suggesting?
no, I'd like to go all the way. I think deprecating rsync is the long-term goal.
It
I
is,
don't have a
but
problem with that.
so that
So-
can stay in that single document, you believe?
Yeah,
Okay.
laying out the full plan and the criteria for moving through each step, et cetera, and then occasional reports on where we are and what needs to be done, et cetera.
Right, but then the moment that you decide to make an actual update to existing RFCs is when you would make a separate document that does that. If I hear you correctly, because this is the plan. It also
Yeah.
confuses being a plan with trying to update actual documents. And that's a confusion that I have with it. If you see what I mean.
I'll have to pretend to think.
So what I'm trying to suggest is that currently we talk about a plan, which is fine. But at some point you may want to execute a phase of the plan. And at that point, maybe what you need is not this document, but a separate document that does that. So a separate document that does the actual update of whatever updates we want to do.
That seems reasonable, and you could either put it in the January implementation report or a separate,
Okay.
RFC 42 bis.
Yes.
Okay.
Okay.
But I want to seriously separate the URI problem, because that's messy.
Yes. There was somebody in the queue earlier, but I missed him now.
For a minute.
Are there any further comments or questions? Oh yeah, Rudiger?
Annoying whatsaboutism. As we are writing down a rollover plan for successive protocols, would it make sense and help not only to increase the complexity of the stuff, but actually for the target protocol specify preference or make the newer IP protocol mandatory, V4, V6?
Right. So you're suggesting that we should talk about making IPv6 mandatory for the RPKI repositories? Did I understand that correctly? I think that is a fine thing to do, but it's probably orthogonal to this. but I may have misunderstood your suggestion.
Okay, as a participant, I think it would be helpful. Randy had a lot of comment about implementation reports and maybe splitting this draft into a couple pieces. I think that conversation would be good to have on the mailing list if possible. So I would call for Randy to please make an email with the concise 4 points he had, or 5 points. I think the implementation report bit is actually kind of useful and something that's been talked about as part of, have running code that implements the changed draft before we publish the draft, which was also on the list. So I think that would be helpful.
I actually did.
Oh, excellent. I don't have my email up, but okay.
Yeah.
So Tim, was there anything that you wanted to get out of this aside from the
No, I think we're good, and I'll follow up on the list and with Randy on next steps.
Okay, thank you very much. I think the next person up is Job with 2 presentations, and I'm going to stop sharing so he can share.
All righty. Share screen. Is my screen being shared? I don't see.
Oh, sorry, I didn't click the button for you.
You really want to share your screen? Yes. Application window. There we go. So today I want to talk a little bit about a concept called RPKI signed checklists. I also wish to make fun of our CIDR name because it has the word CIDR in it. What am I trying to solve with RPKI signed checklists? It is a very similar approach compared to resource tagged attestations, but it has slightly different, and in my personal opinion, simpler CMS object profile definition. I believe there is a need in the Internet Network Operator community for a industry-wide understood RPKI-based attestation mechanism to facilitate a number of use cases, such as for the peeringthebee.com organization to associate onboarding user accounts to internet number resources, to make bring your own IP space workflows a little bit easier, such as Amazon supports in their EC2 product, or for example, out-of-band distribution of Ghostbuster style information. The differences between RTA and RSC are at a conceptual level not so apparent, but when you start implementing, at least in my experience, attempting to implement RTA, I ran into some roadblocks that I believe do not exist in RSC. I want to emphasize that I have great respect for the effort that RTA represents and appreciate it so much, I copied a lot of the ideas from the RTA draft. Now, RTA suggests that multiple signers subordinate to multiple different trust anchors could together composite a CMS signed object. A issue I perceive there is that there could be key identifier collisions along the trust anchor trees. Whether this figure is founded or not is, I guess, subjective, but this is a roadblock I perceive. There are relying parties that have instances per trust anchor where those instances literally run in separate physical address memory space, making it impossible to validate a multiple signer, multiple TA RTA object. And since there is no industry recognized error handling for cases like this, the conclusion in a validation strategy would be that the object cannot pass validation if there are no common trust anchors. Then furthermore, RTA suggests that the intermediate CAs to form the validation chain upwards to what is published in the publicly accessible RPKI and associated CRLs can be included in the RTA file itself. And it is my interpretation that that is not a desirable property and that it is more convenient for operators to have the concept of RTA or RCA skim as closely as possible to the published RPKI. Then I think from a user experience perspective, but again, this is a subjective interpretation of possible future scenarios, I think the RTA model encourages to sign things with all your resources, whether that's relevant to the business transaction at hand or not, whereas the RSC model invites the operator to only list the resources applicable to the business transaction at hand. But these are minute implementation differences. I think it is important for this working group to focus on what we are trying to achieve, how the industry will benefit from this. So implementation status. I produced an example RSC object that can be retrieved from GitHub, which represents an out-of-band means to distribute RSC objects. The example chains upwards to the right NCC operated trust anchor. So validator implementers should be able to use this object to extract the hashes that are encapsulated in the e-content. Then a second signer implementation that is open source was provided by APNIC and can be downloaded from their GitHub account. In terms of validators, there's also two efforts underway. There is a work in progress development branch within the RPKI client project, pending IANA early allocation. And APNIC also provided a validator implementation that can be accessed via their GitHub account. So what we have so far is a ASN1 formal notation, a description in natural language, and two software efforts. I have requested the Sidrops chairs to start the IANA early allocation procedure as outlined in RC 7120. The purpose of early allocation in this specific context is that it would be undesirable for my personal private enterprise number to be deployed in the wild in some capacity, and to further interoperability with future implementations, it is good to obtain a OID from the appropriate IANA registry. Now, some have perceived problems with RTA and RSC, and there are discussions related to identity. But I want to emphasize that the OIDs come from an infinite code point space, and there is no scarcity. Furthermore, the RPKI signed checklists are distributed out of band, and this means that their existence does not place any additional burden on the global RPKI. The CRL checking, which is online, can piggyback on existing fetch operations that relying parties perform anyway for route origin validation purposes. So for instance, in the case of Fastly's deployment, once an hour, the fetching operation occurs, but any subsequent validation of RTA or RSC objects can leverage the cache the validated cache that exists within the Fastly administrative domain without having the need to reconnect to the internet. And then lastly, certificate authorities are not mandated to produce either RTAs or RSCs. So this is a technology that if you do not wish to use it, by all means, don't use it. Then on the complicated topic of identity versus authorization, it is good to keep in mind that when working with RTA or RSC objects, that the trust anchor is assumed trust and there is no derived trust. And this means that if you have a RTA in hand and you want to validate it, you do not know who produced the RTA or RSC object, but you do have a notion of who handed that file to you. And this is what makes that I believe it is possible to use these types of objects in message digest authentication procedures, and how I think this industry can make productive use of this concept, even though you don't know exactly who signed it. You do know that somebody under the trust anchor signed it and that you can validate up to the trust anchor. So how do you implement RSC? It really, to me, appeared as linking a lot of existing ideas that have been expressed in existing code, and that you recombine those individual components to produce a validator that supports RSC. This slide, in part, is intended to be a little bit humorous, but what it boils down to is that there is concepts in the ROA handling, concepts in the manifest file handling, and concepts in the extension handling of existing validator implementations that, if recombined, result in support for RSC files. And this is possible because the RSC specification very closely follows the RC 6488 template, meaning that the initial cost of implementation and the subsequent cost of maintaining the validator code, I believe, are lower than what would happen in the case of RTA. And with that, I would like to open up the floor for questions, comments, anything the group has to share. I see Tim Bransels raised his hand. Tim, go ahead. I will mute myself.
All right. Yeah. So first off, I think RSC in and by itself has a place for the more simple use case, which is what you want to address compared to RTA. Just a point that RTA was not only about having multiple parties signing. The other thing it contained was the idea that you could actually include the cryptographic material needed for validation inside the CMS, which is not allowed if you follow the RPI signed object draft. RFC. So I guess what I'm trying to say is that there are at least two other use cases that exist in the world. You could have a situation where multiple parties want to make an attestation about a shared pool of resources. You could also have models where you want to give something to somebody else who can then validate that by itself without needing to do a full API validation in other regards. That being said, we need to think about where we're headed with the RTA specification. But one option might be that we actually look at the RSC specification and see if we can wrap that in a way, because essentially you could just include these objects. You could have multiple objects if that makes sense for your use case, so you can present them in one go. And if it's useful for use case to have all the CA certificates and CRLs readily shipped with it, so you can make a validation quickly, like, is this thing valid right now? Then that's also something you could look at in an enclosing structure, let's say. So sorry, those were a lot of words, but what I'm trying to say is I can see the use case for the simple case, and I think we need to think about whether the RTA keeps its current specification or tries to leverage this in some way, in summary.
Thank you for your comments. Yeah, I want to emphasize that from my perspective, RSC and RTA are not mutually exclusive. They describe different semantics. One allows multiple signers to attest a single SHA-256 hash, whereas the other has a single signer allowing attestation of multiple SHA-256 hashes. And this makes the ideas fundamentally different. But from a getting things done perspective, I think this industry has been waiting for a significant amount of time for the RPKI community to deliver some kind of technology that fits into the workflows we both agree on exist. So my take on it is that the RSC effort should proceed so that the simple case is covered, and separately discussion can continue on what RTA means and whether it's feasible. But as implementer, I had trouble implementing RTA in its current form, which is more a reflection of my limited capabilities than, of course, the RTA specification in and of itself. If you want to respond to my verbiage, please go ahead.
Yeah, okay. No, I don't have a lot to add, except we do have working implementations of RTA. But of course, I mean, it's a draft, it's a work in progress, but yeah. If you want a data point that it can be implemented and can be interoperable, we have done an implementation at the Nelnet Labs, and EPNIC have done an implementation as well, and they work well together. So it is not impossible, but I agree that it's a more complicated model than what you're suggesting, and I can see how that also has a place.
Reading the comments in both software projects, it was my interpretation that the validation on RTA objects where intermediate CA objects are present has not been finished. And similarly, the APNIC demo of RTA with multiple signers under multiple trust anchors, I'm not confident that that is a robust validation strategy, as it requires multiple instantiations of the OpenSSO command. I could be wrong. I mean, arguably there is some code. I'm just not 100% sure that it is a perfect, robust fit for what is described in RTA. But this can be attributed to my limited abilities, and my hope is that in the RSC proposal, these complications do not exist, and that the working group consensus arrives at that point.
See no other questions. Next presentation, please.
Okie dokie. I pressed the share screen request. I think you need to exit, Chris. Thank you.
Yes. Yeah.
Oh, there. We're going to talk about the validation algorithm. Quick recap. What is the problem we're solving and have been harping on for multiple years, almost a decade now? When an intermediate CA shrinks, any subordinate CA also need to shrink as soon as possible. But there's no signaling mechanism from parent to child to allow for a shrink ahead of time concept. And following the validation algorithm described in RFC 6487, which is the algorithm that all RPs use on all existing objects, all objects subordinate to an overclaiming CA become invalid. In practice, this leads to IP transfers for a period of time, causing unrelated RPKI objects to become invalid. And I believe this is an undesirable characteristic of the system, especially if one considers that validation state impacts the state of the global BGP routing system, especially if people carry validation state in BGP communities. So this, to me, appears as needless brittleness of the RPKI technology stack. A real-life report on the problem is available at this RIPE NCC hosted routing working group mailing list message. The message and the mail thread may be somewhat confusing because two problems are being discussed in the same mail thread. On the one hand, there's a problem description of a validator rejecting objects because a single object listed on a manifest somehow did not pass simple object validation, in this instance overclaiming. No, I'm confusing. Expiration, I think, was the issue here. And then separately, two ROAs related to the CA that sold off or leased off or whatever happened, some IP space became invalid. So there's a ton of objects that became invalid, but that has been handled in updates to the RPKI validator in question. But still, there were two objects that, in my opinion, needlessly became invalid. And how did we end up here? Because we know about this problem, and there's a ton of IETF literature on the problem and even proposed solutions, but the problem has not been solved, is what we observe in our operational reality. I think a challenge here is that the algorithm described in RFC 6487 and the algorithm described in 8360 both are valid algorithms, in the sense that both, given a input, produce a deterministic output. And which of the two algorithms is better, to some degree, is a subjective matter. Both arguably provide a means to validate, but one compared to the other have different behavioral characteristics in operations. And Ben and I prefer a little bit less operational brittleness, as long as it does not come at the expense of security. So from this perspective, I think the 8360 algorithm is superior to the algorithm that was specified earlier on. And we have to keep in mind that validity is in the eye of the beholder. CAs do not control what the RPs are running on their servers. The RC8360 algorithm does not introduce weaknesses, in my opinion. And the authors of 8360 stipulated this opinion in the security consideration section. So I think that the RERs or any other CA don't need to dictate how an RPKI relying party validates the information fetched. The relying parties will execute a validation algorithm, which may or may not contain defects, and only the relying parties are in a position to choose which algorithm or which software they want to use to validate the RPKI data. Requiring certificate authorities to set a new policy OID in order for relying parties to begin using an improved algorithm, to me, appears as an unnecessary step. because as is evident from the 8360 document, there is a ton of duplication in terms of the extensions used to achieve the deployment of the improved algorithm. In other words, I think that the profile agility procedure described in RC 6487 has caused a change that would be perceived by many operators as backwards compatible to become a breaking change, all for no obvious benefit. So how do we dig ourselves out of this situation? It is in the IETF process possible to perform the following plan. A new document can update the 6487 RFC and replace the algorithm with a different algorithm, repurposing existing code points. Then furthermore, I would suggest that the profile agility section, which caused us to end up in a RFC 8360 undeployable scenario, is removed, as it is not clear that this procedure is correct to begin with. I think future work will need to reevaluate whether the agility procedure is appropriate or not. And as a consequence of updating 6487, there is no longer a need for RFC 8360. Therefore, I think it can be deprecated. In all of this, the RARs and intermediate CAs are not required to take any action. From an implementation perspective, I think this is very doable. These are 3 examples to achieve such applying the new algorithm to existing objects. All 3 examples should be fairly readable and straightforward. And what this means to me is that only a handful of people need to commit changes for the improved algorithm to propagate throughout the ecosystem. I, for one, would be very keen on getting my hands on a validator that uses the new algorithm rather than the old algorithm. So what about existing work? And I do think that as an RPKI community, we have wasted an incredible amount of time, especially considering that some already knew before RC 6487 was published that there would be operational issues down the road. So the X509 policy extension is not wasted. It can be used in the future. What is wasted is the policy OID associated with 8360. But the good news is this comes from a infinite code point space, and there is no, as far as I know, existing deployment of the code point. So deprecating this code point, I think, is has no downsides. And for most relying party implementations, it would mean that a bunch of code can be deleted, which might help simplify the code base. So with all this in mind, and the draft itself, which I do encourage people to read, it is a complicated draft because it deprecates and updates multiple other documents. But fortunately, as shown in this slide, if you click any of these URLs, you will find that the changes required in code are very simple compared to what is required in the IETF process context. And I want to implore on people that we are running a live system. This is deployed in production, and this means that any changes, such as a validation algorithm change, need to be absolutely incrementally deployable without the lockstep dance that the 8360 RFC was forced to follow. So we're changing the tires on a live system, and I do think it is possible but it is a complicated dance. So with that, we have time for questions and comments. Anybody? Yeah, I would love to hear feedback on this.
Seeing no other questions, Job, your request to start the code point early allocation, we can do that shortly. Yes.
The IANA early code point allocation is for RPKI signed checklists. This presentation is about the RPKI validation algorithm update. And this is a separate task for the chairs to consider starting a call for working group adoption.
Okay. Did you already email the mailing list for that request? I didn't look.
I have not. I will do so shortly. Thank you.
Okay, thanks. I think the next person up is Alex Sazimov. I forgot to ask if Alex wants to run his own presentation or not.
Yes, I need your permission.
Perfect. You have it.
Hope you can see it. Hi, everyone. My name is Alexander Azimov. I work for Yandex, and here is an update on the ASPA drafts progress. There were major and minor changes that happened with the documents since last meeting. I'm not going to describe all the changes. Hope you have read the document and agree that its readability has improved. If you haven't read the latest document, you still have a chance. The next update will be in a month. The next 3 bullets I'm going to discuss in more detail. First, we reach a synchronization point with ARTIA protocol specification, and now ARTIA PDU is in sync with ASPA profile. Though I'm not author of 8.2010 BIS, I'd like to highlight key requirements for ASPA processing. The cache must create a union of providers from all available ASPA records in advance before it sends the data. It must send the union of providers in a single PDU. And router must support the atomicity of these updates. This is crucial to prevent race conditions. And another major update covers issues with access. The behavior of access bring ambiguity to BGP routing. Some of them believe that they are not part of routing process, so they don't add their autonomous system number to the path. Some of them put it inside. Some of them support community with prepending their own autonomous system number. Some of them don't. And it makes the process of verification much harder. And for those who forgot, I love drawings, and there are special terms to read these drawings. If you see circle on top of another, it means that the one circle on the top is provider of the one at the bottom. If there are circles on the same level, they are pairing with each other. And the arrows, most important, they show the direction of ASPA pair verification procedure, not the direction of the advertisement. So let's move on. Here are 2 scenarios. On the left, you can see a scenario with transparent IX. And on the right, you can see IX in the path. The validation of the left is simple. You just need to check pair 1, 2, and it is the correct pair, and everything is valid. On the right side, the situation is a bit harder because 2 haven't authorized Atom system that belongs to the Internet Exchange Point to advertise it to its upstream providers or peers and so on. So it's a very specific situation where we have the system in the middle, which acts like a provider, but it's not mentioned in the list of providers in the ASPA. But we can imagine that 2 is a peer to IX, and 3 is its customer. In this case, we can apply downstream verification procedure, and it will be fine. So we will have 1, 2 as a valid, 2 IX is as invalid. But if we apply downstream procedure, it's okay because it just highlights the end of upstream segment, and everything works fine. And in previous versions of the document, we suggested that to make it a general policy, just apply to all routes received from the route server downstream verification procedure. Unfortunately, there was a shortcoming. And here it is. The problem is that it was limiting the opportunity of IXP members to detect route leaks. The problem occurs on the left side, where the transparent IX is presented. In this case, if we apply a downstream verification procedure, we will have 1, 2 as invalid, but it's okay. Well, it's not okay. So on the right side, everything is fine, but on the left side, 3 is unable to detect a leak that happens on the other side of transparent IX. So we decided to change the procedure and to use the presence of the IX in the path as a token. So if Atom system that belongs to IX is present in the path, we will apply a downstream verification procedure. If it is received without IX in the path, we will apply upstream verification procedure. This way of processing looks both safe and efficient in terms of leaks detection. So this is the major change that happened with the documents from the last version. And I believe it's quite important because the ability to distinguish, to detect leaks, to distinguish invalid paths from anything else is crucial. And let's jump to another observation that was found by Jakob and Sriram and already discussed in the mailing list. Please look at these 3 scenarios. In all of these scenarios, I found a bug in this, 3 is receiving prefixes from its provider with Atom sys number 2. And it proves out that it doesn't really matter the peering relation between 1 and 2. It may be custom, it may be peering, it may be provider. So with any kind of peering relation between 1 and 2, this scenario ends up with valid. And the observation that was found that, so if the relation doesn't really matter, even if 1 haven't created a space, so the pair 1, 2 is unknown, we can still treat this kind of paths as valid. So to make it clear, this doesn't improve leak detection. Though at high adoption rate, it can be useful by improving the number of valids comparing to unknowns. There are already a couple of ways to implement this logic. We discussed it in a small group of list. But the discussion about semantics that represents this change in logic looks even more important at the moment. So here is the plan for today. We need to finish the discussion about valid states in case of downstream paths, or what we just discussed. It may result in important wording changing inside the document. We need an updated 8210 bis, and for some reason it's missing. And I think with this document in place, we will be able to start working group LASCO for all documents that are related to ASP. I think that's all. Any questions?
There's a Randy in queue.
Yeah,
Randy?
the reason you cannot find 8210 bis is because you're looking for a YMBK document and it's an IETF document.
Ah.
It is waiting last call for you to stop changing this draft.
Okay, great. Because for some reason I was looking for this document and I was finding only 00 with YMBK. It's good that I missed it, but it is exist. Any other questions?
I don't think there's any other questions in queue.
Okay, so I'll pass the ball to Shriram. He will give you more details on the topic of that we just discussed. And I hope the next update to the document will be the last one before working group LASCO.
Okay, Shriram, you should be able to present, or I thought so. Okay, now you can.
Yeah.
Okay. And as a short reminder, we have about 30 minutes left. So if you want questions, make sure to get it in under the 30-minute wire.
Sure, thank you. You can see my PDF. This work is done jointly with Jacob, and
Not
slides, yeah.
It's not quite displayed yet. I think it might be asking you to accept the screen share, blah, blah, blah thing.
Okay, let me go back. Share your screen, your entire screen, application window. Okay. Is it good now?
Perfect. Thank you.
Yes, thank you. So this is Sriram. This is joint work with Jacob. We've been sharing these slides for the last 3 weeks or so on the Sidrops list. Several people have taken interest, looked over the slides, and we got some reviews, some comments back. In particular, Alexander and Ben Madison have taken, as well as TAs from RIPE, they have taken a close look at these slides. In general, there is agreement that, yes, we have an opportunity to improve the AS path validation. Next slide. One moment. Yeah, that works better. So the key takeaways from this talk are the following. The downstream AS path algorithm, there's an oversight in the draft, as Alexander has already mentioned, and there is an opportunity to improve on that, and that's being done through some private conversations between Jacob, myself, Alexander, and Ben Madison. So that's going to be coming forth soon. The corrected, so in this draft, we try to show that correct algorithm exists with formal proof, and it classifies valid, invalid, and unknown AS paths correctly. So it's we think that this algorithm is also efficient because later on when I present an implementation procedure, there we strive to minimize the ASPA lookups. So this is that would be a candidate way of implementing this algorithm. And as I know, or mentioned, Alexander and Ben are actively working on versions of implementation of this. So to get started with this whole idea of looking for the correctness of the algorithm, it is very helpful to have a ASPA hop check function. Similar thing is also mentioned in the current draft, but it doesn't use give it a name. Here we are giving it a name that is G. So G of ASI ASJ is P if ASI attests ASJ as a provider. It is NP if ASI attests ASJ as not a provider, and NA if ASI does not have an ASPA, no attestation. And if you have a hop from I to J, as in the middle, and depending on whether I to J, the G function, the hop check function is P or NP or NA, you have different possibilities for that hop. So clearly, if it is P, only possibility is an up link, customer to provider. And if it is NP, then it could be down or lateral, peer-to-peer. And if it is NA, then all three possibilities are open, up, down, or lateral. So we'll use this notation in the discussion. So this is the example that Jacob originally mentioned on the Sidrops list. 1 and 2 have ASPAs, 2 and 3 don't have ASPAs. In this case, clearly the path is valid because 1 to 2 is a valid customer to provider, and 3 to 4 is a valid provider to customer in the down direction, and the validating AS is after 4. So clearly the path is valid because it doesn't matter between 2 and 3 what that link is, whether it is up, down, or L. In all three cases, the AS path is valid from the point of view of route leaks, from the point of view of valley free. So it's valid. The current algorithm calls it unknown. So that's something that we all agreed on. The next 2 slides, it's just another example where 3 can have an ASPA and still the same thing happens. And the third example, you can insert a number of sibling relationships in the middle, like 3 to 4. They are mutual transit. They each have ASPA pointing to the other as a provider. So they are, as a result, they are siblings. So you can insert any number of these, and the same thing happens as in the previous 2 examples. The ASP algorithm determines the path to be unknown, but it is indeed valid. In terms of fixing that, we make a few simple design principles, observations. Again, we are focusing on the downstream AS path only. So here the first bullet is AS path is valid if there is an up ramp of customer to provider hops on the left, there is a down ramp of provider to customer hops on the right, and those 2 up ramp and down ramp are completely verified based on ASPA. And in the middle, if you have no hops at all, they are a perfect inverted V, these 2 up ramp, down ramp. Or in the middle, you have a single lateral hop a single hop that is either NP or NA. In that case, the path is valid. And the second bullet is making the same observation in a slightly different wording. If every transit AS has at least one neighbor that attests it as a provider, then the AS path is valid. So the situation when the path is valid is absolutely clear. The next question is, when is the path either invalid or unknown? And the answer to that is that if you have 2 or more hops in the middle between the up ramp and the down ramp, in the middle, if you have 2 or more hops, then the following can be said, and that helps to separate the invalid from the unknown. If there are opposing values, so that is NP hop from left to right, and a subsequent NP hop from right to left. So one NP hop from left to right and another subsequent NP hop from right to left, then no matter what is in between, there must be at least one value in the AS path, and hence it is invalid. The draft algorithm also recognizes that. And if this is not the case, then the path is unknown. So the key thing is this separation of the path, the representation of the path in terms of a valid up ramp on the left, and a valid sequence of down hops on the right, a down ramp. And at the top, if you have no hops at all, 3 and 4 are the same, or you have a single hop, no more than 1 hop at the top, which is unknown, or not. 3 to 4 is not provided. In either of those 2 cases, the the path is perfectly valid. So you have either a perfect inverted V, or you have an inverted V with 1 hop at the top. In both of those cases, the path is valid, given that the up ramp and down ramp have been verified to be correct based on ASPA. So moving to the next one, this representation helps in terms of formulating the design problem in a systematic way. This is scale representation of the downstream AS path. AS1 to ASN is the whole AS path. And on the left, you have a series of customer to provider hops. All of them are valid according to ASPA. On the right, you have down hops, L to n-1. And again, all of those are valid according to ASPA. So once you have identified this valid portion on the left and the valid portion on the right, then you can have peace of mind with regard to those 2 ends. That allows you to focus in the middle from K to L. And first thing we know is that the very first one, K to K plus 1, it's not a provider. It is either a NA or NP. And likewise, on the right side, L to L-1, again, it's not a provider. It is either NA or LP. We know that for sure. In the middle, you may have in all these 3 possibilities: provider, NA, NP, doesn't matter. So this is the kind of representation we have to start with. And an example of that representation is this one, where K is 3 and L is 6. And in this, we show the ASP is in the middle. The 3 to 4 is either NP or NA. That is what breaks the up ramp and then or terminates the up ramp. 6 to 5 is NA or NP, and that is what terminates the down ramp. So that is how we define K and L. K is 3, L is 6. So in this example, naturally, this is not going to be valid. We cannot say that it is definitely valid. It will either be invalid. We'll be able to show that 3 to 6 has a value-free violation, or we will be able to show that it is a mix. There are some possible trajectories between 3 and 6 that are valid, and there are other possible trajectories between 3 and 6 that are invalid, in which case this middle portion will be unknown. As a result, the whole path will be unknown. So for that, one more observation before we go to the theorems. L is less than K. It is perfect. It is possible and perfectly fine. That means that the up ramp and the down ramp overlap, and that happens when you have sibling hops in the middle. So no issue with that. The algorithm would still be fine. So just to take a quick look at the theorems based on what we have discussed so far, the theorems kind of start to emerge as like obvious pretty much, but we have proof in the appendix, in the backup slides, the proof is given. So the first theorem says that if you have L minus K less or equal to 1, then the path is valid for sure, and that is the only, if and only condition under which the path is valid. And if L minus K is greater than 2, then the path cannot be valid for sure, but it is either unknown or invalid. Theorem 2 further helps us by differentiating between the unknown and the invalid. Here it says that if you look at this middle path K to L, or for that matter, you can look at the whole AS path 1 to N, doesn't matter. If you have a hop on the left, that is U to U plus 1, that is not a provider. And if you have a hop on the right of that, V plus 1 to V, that is also not a provider, then this middle portion of the path is invalid, and the whole path, AS path, is invalid. Otherwise, the partial path is unknown and the whole path is unknown. So those are the theorems. So just a quick glimpse of like the proof or the validity of that theorem. We look at the case when L minus K equal to 2. If you have two NPs from left to right and right to left facing each other, then the path is invalid, because you will construct from this, you can construct the 4 different trajectories between 3 and 4, and you will see that out of those trajectories, all of them result in value-free violation, and therefore there is no trajectory which is valid. All of them are invalid. So this 3 to 4 is definitely invalid if you have two NPs facing each other. All other combinations, NA, NP, and NA, NA, NP, NA, those 3 combinations, you can construct trajectories between 3 and 4. Some would be valid, some would be invalid. As a result, you will call it unknown. So that's the general idea of the proof. And we show it for L minus K equal to 3 in the backup slides. And also from there, you can use the method of induction to provide a general proof for the theorems. So with the help of those theorems, it's now pretty simple and straightforward to lay out a crisp description, which you pretty much already know at this point. If the S path length is less than or equal to 2, then the path is valid. It's trivially valid, and we don't need to apply the ASPA at all in this case. Then, if the path length is greater than 2, then we can have the LK formulation, and if L minus K is less or equal to 1, as we said before, the path is again definitely valid. So now we consider L minus K greater than equal to 2. We have already said about that if you have these two opposing not provider hops, one on the left, one on the right, they are facing each other, like in this previous slide, NP are facing each other, it's going to be invalid, and otherwise the path is unknown. So I'll not go through this, my last slide here. It is basically laying out an implementation procedure. We tried to squeeze the most efficiency into it by minimizing the number of ASPA hop checks. So people who are interested in the implementation can take a closer look at this and see if this is something that they would like to use. Otherwise, the implementation can vary depending on the implementer's taste and choice. But the basic principles remain the same. So with that, I conclude. If you can look through the backup slides at your leisure to look for like the proofs for the theorems or the foundation for this type of algorithm. With that, I can open it up for questions.
Looks like we have about 15 minutes left in the meeting for questions and a quick discussion at the end, hopefully, about the running code conversation on the list. So questions.
Ben and Alexander, feel free to say something if you have some thoughts about your implementation efforts that you are putting in, if you would like to share.
Said that I appreciate your effort on improving ACA algorithm. As I said during my slide, it's really important to keep clear wording and description.
I think, Alexander, your audio was extremely bad.
I'm sorry for this.
That's better.
I can try to repeat. Intention to tend to work but more important than I think it was Ben's point that it's more important to make a clear description, clear wording. It's more important than computational efficiency even.
Yeah, sure. I don't mind. I mean, what I looked at, what you were trying to do, the discussions we had, and I still have to dig deeper into Ben's implementation. It seems like that the basic principles are similar to or same as what is described in these slides. So yes, if the efficiency is not of topmost priority, then yeah, there are variants that can definitely be implemented, but still based on the principles outlined.
Ben here. I think just to echo that, I think we have three kind of algorithmic or in-code representations of fundamentally the same set of ideas now that are more or less equivalent to each other. There's the version in draft 07. There's a version that I wrote based on the email that Jacob sent to the mailing list a couple of weeks back, and there's the version presented in your slides. And I think they pretty much all arrive at the same conclusions in a relatively similar way under the hood. But I think that in terms of what we select to end up in the final document, the two overriding considerations for me are that we should value readability and understandability over efficiency. We don't need an optimized version of this algorithm in the standard. That can be for implementers to do. And secondly, and I think this is the biggest shortcoming of the draft as it's currently written, I think that we need a much clearer line of reasoning to go from what we understand as a root leak of the type that we're trying to detect to what the eventual algorithm ends up looking like. I think setting out that those logical steps are really important to allow people that haven't been, reading iterations of this draft for the last however many years to actually know what to expect in practice if their server winds up running on their routers.
Yeah.
Just a quick interjection. If you're not talking, you need to mute your mic, because otherwise there's a bunch of echo. That's, I think, why Alex wasn't heard and why Ben was cutting in and out.
Sorry about that, Chris. Thank you for reminding, but a little bit too late for Alex and Ben. I just want to add to what Ben just said, that yeah, that's good. And one other thing that I would like to mention is in the draft, the element, the G function that is defined in the slides is quite helpful. So that it's just a matter of, like, in section 4 of the draft, just give it a name instead of saying ASI, ASJ, valid, invalid, unknown. Just give it a name like G, and maybe if you like, use the P, NP, and NA notation, because if you use like if each hop check, if you say it is valid, invalid, unknown, you are kind of saying that my hop is invalid, but the path is valid. So that happens in many cases. So that kind of maybe confuses the reader. So just to make it disambiguous, I would also like to recommend, in addition to using a function like G, just to make it clear, G is a hop check function. I can just give it a name and also use PNP, NA type of notation to keep it unambiguous. Don't mix it up with the overall path validity or invalidity, unknown, etc. So those are my couple of suggestions in rewriting or making the text more useful.
Just a small response that the function has already its name. It's called in the document pair verification procedure, and it is in a separate section from all other procedures that we have in the document. So I do think that the naming of these function is not a problem, but it's my personal opinion, of course.
Yeah, Alexander, we can chat about that a little bit more between you and Ben and Jacob and myself. But yeah, I'm fine either way. I thought I would just make that suggestion for better clarity for the reader. Just a matter of giving it a name. You give it some kind of a name, but a symbol like G might help. But I'm not adamant about that. Thank you.
Okay. Any other questions for Sriram or Alex or Ben, I suppose? Okay. I think thank you very much for your presentation, Sriram, and the other presenters also. Thanks a bunch. There's a bunch of good conversation and some action items to move forward with. The last little thing I wanted to mention, because I said I would mention it last night when I emailed, and I got badgered by at least one participant to say something. I think there was a relatively long conversation, 6 or 8 emails about, getting some running code before we push forward drafts that have implementation changes. That seems totally reasonable to me, and I outlined this in the email reply last night. I think at the very least it gets us an opportunity to see how the changes are going to actually work, how they're going to change the operations of the system. I don't think anybody has necessarily disagreed with any of that in the previous bit of thread. So I think the chairs need to do some work on a little charter update and push that forward through our ADs and the IESG. If there's any comments or questions about that, now would be a perfect time to speak up. Rudiger? Warren?
So yeah, this is Warren. I'm not sure that it actually needs a charter update.
Kind of, I wonder about the terms used. Are we asking for running code or for running code and actually positive interoperability test?
So I'll give Rudiger a second to get back to the listening side of his conversation. Okay, so Rudiger, I suppose in my head, implementation, interoperability, and running code are kind of the same thing to me. That's a bit naive on my part, I totally admit. But the conversations earlier today about, get some running code, get some implementation, and interoperability reports, I think that's all kind of the same thing to me. And that's where my headspace was, at least. So yes, and Warren was in the middle of saying something about maybe we don't need.
Yeah, I mean, you can do a charter update if you like. That sounds like a lot of faff. The other option is just, update the Sidrops wiki or something and have a note that you're not going to progress documents until you have X. Whatever you'd like. If you want to do a charter update, I'm fine to push it through the process. It just requires many buttons and, paperwork and faffy stuff.
I think Job and then Kair.
Yeah, I was going to jump in and say real quick, this is Kair from Marcus, that, having had an experience at IDR where two implementations are strongly required, whether they are deployed or not is a added plus. But showing an interoperability between multiple implementations is what IDR prefers. I think here in this working group, we can start with one. And a interoperability document in some cases would be a added plus, but otherwise we could start minimally with one implementation. I don't think we need, in a lot of cases, an interoperability document, right, Chris?
Yeah, I don't know that a document is particularly required, but it certainly seems like it would be helpful to at least review in a meeting or on the mailing list of kind of formal, hey, we three implementers got together, we ran the bits and pieces, nothing bad happened and the world didn't explode, right? Or, hey, this is actually pretty crappy, we should think about it in a different way.
Right.
Yep.
To reiterate somewhat of what was already said, but I think we should copy a lot of the working group culture in this context from IDR, where depending on the draft at hand, maybe merely an implementation report is required, detailing how the normative terms in the draft are handled by the software, and potentially, depending, of course, on the proposed idea, whether it interrupts with other implementations. Not all ideas require interoperability, but the ones that do, we should definitely be testing. This is not about open source versus proprietary software solutions. Proprietary software solutions are also able to write implementation reports and to perform interoperability testing. So yeah, we should be copying from how IDR handles this. I think it would positively benefit this group.
Okay, we have less than 2 minutes and we get kicked out, so the last people are quick. Doug, Warren, and Randy.
I was just making the point in the chat, right, that interoperability and things like ASPA algorithms, interoperability is only a question where systems interface, right? So that's the interface to RPKI and processing the data. I think what we're interested in is that different implementations behave consistently, which I guess is a broader definition of interop. That's it.
Thank you, Warren.
The more I think about it, the more I think it would be a good idea to just have a strong suggestion that you have interoperability or code requirements or something. That way you have flexibility in the future. So I suggest just have it somewhere, not necessarily in a charter, but we can chat more later.
Okay. Randy?
This is an ops group, not a protocol group. Interoperability of what?
If I can jump to Q.
Go.
Randy, for example, interoperability of RSC or RTA or other newly defined objects in the RPKI. we can confirm whether multiple different implementations are able to understand according to the specification proposed.
Okay, but they don't belong here. This is Cider Ops, not Cider. If you want protocol that needs interoperation, then it needs to be done somewhere else, or this group needs to move out of ops and have a massive recharter.
The fact remains that currently things like RTR are handled by this working group, and I do think it is good to show and demonstrate that multiple systems understand the specifications. And I'm not opposed to rechartering and splitting things back into Cider versus Cider Ops, but running code will help us.
Okay. Last thoughts, Doug or Kayer, whoever.
I forgot to take my hand down.
Kayer. Okay, maybe Kayer's comment was the comment in the chat about this may slow it down some. I think with nothing else, we're about to get kicked out, and thanks everybody for participating. If there's open questions, please put them on the mailing list. Kayer, go.
No, I'm good, Chris. I'm good to go. Thanks.
All right, thanks. See you guys in 3 months. If we need to do something between now and the next meeting, please be vocal on the list so we can schedule an interim kind of at any time. See you in 3.5 months or whatever. Virtually, probably. Bye.